In this presentation, we will talk about Meissner effect. Meissner studied the behavior of a superconducting material when it is placed in a magnetic field. We know that the normal conductor allows the magnetic field to pass through. However, a superconducting material does not allow the lines of forces to pass through it. Meissner placed a superconducting material in a magnetic field and maintained the magnetic field strength lesser than the critical field, and the temperature of the specimen also lesser than the critical value. At that moment, he observed that the magnetic field lines are expelled from the interior of the specimen. This means that the magnetic field lines are deviated from the interior of the specimen. Therefore, the specimen is maintaining its superconducting property. After that, Meissner increased the temperature of the specimen to a value greater than the critical temperature and also increased the magnetic field strength to a value greater than the critical field. Now, the magnetic field lines are passing through the specimen, and it specifies that the superconductor is changed into a normal conductor. So, the transformation of normal conductor to a superconductor is possible if the temperature is lesser than the critical temperature and the magnetic field value is lesser than the critical field. Now read out this statement. When a superconducting material is placed in a magnetic field, the nature of the material depends on its temperature and the strength of the magnetic field. The material acts as a superconductor at a temperature lower than the critical temperature and a field less than the critical field. T less than Tc, H less than Hc, it is a superconductor. On increasing the temperature and the field more than the critical values, the material is acted as a normal conductor. Say T greater than Tc, H greater than Hc, normal sphere. Now read out this statement. The phenomenon of expulsing the magnetic field from the interior of the superconducting material is called the Meissner effect. Now we have to give the prompt explanation for this. The magnetic field B is equal to mu naught into H plus M. Now take out this H outside, you can get 1 plus M by H. Here magnetic susceptibility chi equal to M by H. Here M is intensity of magnetization, H is the field applied. The ratio of intensity of magnetization to the magnetic field applied is called magnetic susceptibility. Therefore, the magnetic field B equal to mu naught H into 1 plus chi. According to Meissner, B equal to 0. In a superconducting material, the value of B equal to 0. Therefore, mu naught into H into 1 plus chi equal to 0. If you substitute B equal to 0 in the above equation, mu naught into H into 1 plus chi equal to 0. But mu naught into H not equal to 0 because we are applying the field. Therefore, 1 plus chi equal to 0, chi equal to minus 1. From this equation, chi equal to minus 1. A diamagnetic substance is having negative susceptibility value. Then we may point out that all the superconductors are perfectly diamagnetic because the value of B equal to 0. Then we may go for isotopic effect. The critical temperature of a superconductor is inversely proportional to the square root of the isotopic mass of the element. Tc is inversely proportional to 1 divided by m power half. This is modified as Tc into m power half is a constant. To remove the proportionality sign, we have to use a constant. T is equal to constant divided by m power half. So Tc into m power half is a constant. The debate temperature of the phonon spectrum is also inversely proportional to the square root of the isotopic mass. Theta suffix d, debate temperature, is also inversely proportional to m power half. See, this is also m power half. Care should be taken. M power 1 by 2. That is root m. From this we can write theta d into m power 1 by 2 is a constant. From these two equations, say this is equation 1, this is equation 2. From the equations 1 and 2, we may write Tc by theta d is a constant. According to Meissner, the value of B is exactly 0. But London pointed out that the value of B is not exactly 0. It decreases exponentially. Now we have to discuss about the same in the case of London equations.